Researchers at Queen's University present a calibration technique for projecting digital images on arbitrary surfaces. The calibration technique shown in this video was created to be used in short-throw projection systems using inexpensive, off-the-shelf components without the restriction of using a planar surface. To calibrate an unmodified conventional data projector, the hardware requirements include a camera to acquire images of the projection surface, and a computer to process the images and to output to the projector. Both the camera and the projector are connected to the computer. Adding a convex mirror allows for a simple short-throw configuration without the additional cost of a custom and complex lens system. Freeform surfaces exhibit nonlinear geometry. This surface contains a large non-uniform wave running throughout it, primarily in the horizontal direction. The nonlinearities of both the convex mirror and the surface cause the projected images to appear extremely distorted. The calibration is performed by projecting levels of gray-coded patterns and their inverses. Patterns resembling vertical stripes encode the x dimension of the projector coordinate space, and patterns resembling horizontal stripes encode the y dimension. Images of these patterns are captured by the camera and transferred to the computer, where they are decoded to recover projector-camera correspondence pairs. Two images are used to test the calibration: a photograph and a synthetic chessboard pattern. Without calibration, the photograph appears distorted and elongated towards the top. This animation shows the image being corrected using the calibration data. The result is a projected photograph which appears undistorted from the viewpoint of the camera. This uncalibrated view of the chessboard image makes the curvature of the screen more apparent. This animation shows the extent of pre-warping required to correct the image. This is the final result. The calibration used here processes 7 levels out of a possible 10 levels of gray code patterns. The accuracy of the results can be improved by using more levels. It is also possible to calibrate using fewer levels. However, as the number of levels decreases, the amount of interpolation increases. The accuracy will decrease and the size of the unusable edges will increase. The calibration can only be performed from a single viewpoint in the room. The camera is placed in the position of this desired viewpoint. Because of this natural limitation, the results will not appear perfectly correct from other viewpoints. This technique not only works on freeform surfaces, but also works on planar surfaces and multiple planar surfaces. A multiple planar surface contains 2 or more planes in different positions, such as the intersection of 2 adjacent walls. The calibration creates a perfectly rectilinear chessboard from the viewpoint of the camera. However, the further away we move from this viewpoint, the more distorted the chessboard becomes.